So here is another problem on how to apply the gamma function. So we are going to transform the integrand so that it takes the structure of the gamma function, and then once we have the structure of the gamma function, we express it into a factorial and then easily simplify the expressions to find the exact value of each of the two given improper integrals. So work with me in solving the question. So the first integral is 0 to infinity of y power 3 e raised power negative a half y squared, and then dy. So that's the problem that is at hand. So then now we start by fixing. Remember, if we had 0 to infinity of y power 3 e raised power negative y dy, we'll actually be happy to say that this is definition of gamma of 4, because you can write this one as 4 minus 1. But then the value of the power of the exponential is not negative y. So this is a problem on this particular integral. So we'll fix it and say let u to be a half y squared. So which means the u is given by y dy, just by power rule. So which means dy is the same as du over y. Now, this will now be, so limits also will have to see whether limits are changing. Now, when y is 0, then u will be given by a half times 0 squared, which is 0. And when y is infinity, then u will be a half infinity squared, you still be infinity. So limits are unchanged. You must always confirm what happens to the limits when you're doing the transformations, because in some problems, you will find that when you introduce a new variable, limits will not remain to be the same. Now, so therefore this integral 0 to infinity of y power 3 e raised power negative a half y squared dy will be the integral from 0 to infinity. So let me write this one as y power 3, and then e raised power negative u, because I've fixed this part to be u. And where this dy, we put du over y. So by doing this y and 1y cancels here, so we have 2. So I'll have integral 0 to infinity y squared e raised power minus u du. But you see from here, we also have y squared multiplied through by 2 is 2u. So the place where we have y squared, we can comfortably replace by 2u. So this will be given by integral 0 to infinity 2u e raised power negative u du. So 2 is a constant, so pull it out. So 2, 0 to infinity, u is like u power 1, so power is 1, e raised power negative u, and then du. Now, because the limits are as per the limits on the definition of the gamma function, and this power of the exponential is also in the correct format, we only now write this one as n minus 1. So the same as 2, 0 to infinity, u raised power 2 minus 1, e raised power negative u, du. By doing that, then we have the structure of the gamma function, this part, and which is the definition of 2, this gamma of 2. And we know that gamma of 2 is simply given by 2 minus 1 factorial, and 2 minus 1 is 1, so I'll have 2 times 1 factorial, the same as 2 times 1, and the answer will be 2. So therefore, the integral from 0 to infinity of y power 3 e raised power negative a half y squared dy is nothing but positive 2. So this is the final solution, the question. And then the second part, we were to evaluate the integral of so 2 integral from 0 to infinity of square root of y e raised power minus square root of y dy. Now, we also do the transformation by fixing this value. So we say let u be given by square root of y. So let u be root y, with the same thing as saying u is y raised power half. Which is the same language of saying squaring both sides, we have u squared is the same as y. Now, 2 u du, I'm now differentiating both sides of this, so give me dy. And now in limits, must always test before you proceed to transform the integral into a new variable. So when y is 0, u will be given by 0 power half, which is still 0. When y is infinity, u will be infinity raised power half. And because we're only dealing with positive values, then also this will also be infinity. So limits are unchanged. So therefore now, we write integral 0 to infinity. Now where there's square root of y, we put u. Where there's this, we put negative u. Where there's dy, we put 2u du from this result. Now here we factor out the constant 2. So we'll have 2 integral 0 to infinity. Now we'll have u times u is u squared, e raised power minus u du. Now, to get the structure of the gamma function, we simply write 2 as 3 minus 1. So this will be integral 2 integral 0 to infinity u raised power 3 minus 1 e raised power minus u du. So then now, by rewriting the integral in that form, we are successful in converting this part as a gamma function. So we'll have 2 gamma of 3, which is the same as 2 times gamma of 3 is 3 minus 1 factorial, which is the same as 2 times 3 minus 1 is 2 factorial, which is 2 by 2, and we get 4. So therefore, the integral from 0 to infinity of square root of y e raised power negative square root of y dy is nothing but 4. So 4 is exact value of that given integral. Thank you.